So yesterday's examples had one logarithm in them, right? Had one word log written, okay? And if that's the case, then you are going to directly use or go straight to the use of the definition of a logarithm, okay? You're going to use the exponential procedure to be able to solve that logarithmic equation. Today, we're going to put two logarithms in, okay? And you might even see 3 or 4, but if we can do it with 2, we should be able to do it with 100, okay? But you might see them on the left of the equation together. You might see them on the right and one on the left, but you need to get them all to one side right now, the way that we're going to do this, okay? So these are already, there's 2 of them. They're already set up on one side, but we have to use a logarithmic property because the only way that we can, so we still have to use exponentials to solve this. We still need to take the base raised to a number, come back and give me the argument to solve this. But to do that, our property only has one log in it. So if I say, basically what's going to happen is that we have to have log base b of x equals y. That's what we need so that we can rewrite it this way, b to the y equals x, because that's going to allow us to solve it, right? Okay. We don't have this. We have something else added on to it right now, and that's a problem. So I can't go straight to this yet, okay? So we need a way to get these to merge to one thing. You guys remember saying that if I have log base b of, let's say, m plus log base b of, let's say, n, how you can rewrite that with one log? Because remember what addition turned into with these things? Multiplication. I can rewrite it that way, can't I? So, when we have log base 3 of 4 plus log base 3 of 2x, can I rewrite that as log base 3? This is addition. So what am I going to do with the 4 and the 2x? Multiply them together. Gives you 8x. Okay? And that should then equal 5. Is that something we can do? Now it turns into yesterday's problem. We now have this situation occurring. Log of a base of some argument equals y. So then I can take my base, which should be 3, raise it to the 5, which is my exponent, and that should come back and give me 8x. Okay? Now, 3 to the 5th, so 3 times 3 is 9. Okay, so that's multiplying it twice, right? Okay. Times 3 again would be 27. Times 3 again would be 81. So we're up to 3 to the 4th is 81. So 3 to the 5th is another, so at 81 times 3 would be 243. So this is actually 243 equals 8x. Divide both sides by 8. And we have our solution. 243 and 8. The only factors of 8 are 2 and 4, right? 243 ends in a 3, so it's not divisible by 4. And therefore, it's not divisible by 2. We can check ourselves. Take our Desmos calculator. So we go log base 3 of 4 plus log base 3 of 2. Now I'm just going to say 2a because I want to plug in a. If I use x, it'll try to graph it. If I plug in a equals 243 over 8, does it evaluate this thing to be 5? Which is what we originally wanted, right? Okay. Seems that some of us are not doing this stuff. Okay, writing stuff for other classes, typing, that kind of thing. Let's pay attention here. Let's go log base 5 of, let's say, x plus 3 equals log base 5 of 14 plus 10. Something like that. All right, so we've got logs now on both sides, right? In order to do this, so, and we'll talk about this tomorrow. If that 14 wasn't, or sorry, if that 10 wasn't there, if that plus 10 was gone, this would be a really easy equation to solve based on what we learn tomorrow, okay? But because of that plus 10, we have to get all the logs on one side. So I'm going to get all my logs on one side. How am I going to get these? How am I going to get these moved over to the other side? Subtraction. So it's going to look like log base 5 of x plus 3 minus log base 5 of 14 will then equal the 10 that's over here. So that's removing it from both sides, right? Just remember, I cannot merge these. I cannot make them, a lot of people, what they want to do is they want to go like log 5 of x plus 3 minus 14, something like that. You cannot do that. Okay? Just subtract this from both sides, write it as minus log 5 of 14. Now, and the reason you can't do that is because when we get to subtraction of two logarithms, what does subtraction of two logarithms turn into? Division. So if we had log of m minus log of n, that turned into, from about a week and a half ago, we said it's log of m divided by n. So, in this case, it's going to be log 5 of x plus 3 over 14 equals 10. Now you've developed one logarithm, right? Developed one logarithm, so we got this 5 as our base. So that 5. We're going to raise it to that power of 10. And that's going to come back and give us this thing here of x plus 3 over 14. Okay. Now, if you use like 5 to the 10th, and I don't know, it's a large number. I don't know if it's going to be too big. We'll do this two different ways. If I go 5 raised to the 10th power, okay, not bad. So it's 9 million. Yeah. Well, it's tiny in comparison to what it could be. Okay, so that's 5 to the 10th is equal to now x plus 3 over 14. What are you going to do to solve this for x? multiply both sides by 14. Multiply by 14 there. Come over here. Multiply by 14 there. Huh? This number here? Yep. So I'll do that for us. So that turns into 136,718,750 equals x plus 3. Now how do I solve for x? Subtract 3. So I get 136, 718, 747 will equal my x value. Now, I hate dealing with large numbers. There's an entire course, there's an entire branch of mathematics that it's called number theory, that you deal with essentially prime numbers and division, and it's very complex. But what it allows you to do is not have to deal and do calculations with those very, very large numbers like this. What I would do in this situation, because would you guys agree that this is a nasty number to mess around with? So if I'm at 5 to the 10th equals x plus 3 over 14, okay, we can multiply both sides by 14 right here. It's going to be 14 times 5 to the 10th equals x plus 3. Does that make sense? How do I solve for x there? You want to subtract 3 from here? So subtract 3 from both sides. And if I write it that way, which if we look at Desmos and compare them, okay, that right there is exactly the same thing we came out with as the kind of expanded value. Right? Now these numbers in your homework, you're not going to have numbers this ridiculous because I just took these off the top of my head. Okay, there's a little bit more thought into the size of the questions. I'm not saying it's out of the realm of possibilities, but generally your number is going to be a little bit smaller than that. But if we type in log base 5 of a plus 3, okay, which was the left-hand side of what we started with, and we type in log base 5 of 14 plus 10, okay, and now make a this number of 136,718,747. Do these two sides of the equation equate to one another? Okay. Let's do this equation. Stop me if something doesn't make sense. If you need something re-explained. Okay, so here we've got log base 9 of x plus log base 9 of 3x equals 2. Same as the first question we did. They're already on the same side. The logs are on the same side. And it's addition. So what does addition turn into? Multiplication. So we merge them together. What's x times 3x? 3x squared. Okay, so we do something like that, right? Now, I can apply the definition of a logarithm. I can say 9 to the second power should equal 3x squared, right? What's 9 squared? 81. So we get 81 equals 3x squared. Yesterday we talked about equations that have an x squared, but no x to the first. So I do what? I'm going to square root, okay? First thing I do, though, before I make the square root, I'm going to get rid of that 3. What's 81 divided by 3? 27. So 27 is equal to x squared. Now I'm going to square root. Square root that. Square root that. Now, when you square root, when you introduce the square root, you get a plus or minus. Okay, it's 2 answers. So we can say x is equal to plus or minus radical 27, or, you guys remember taking 27? What are 2 numbers that multiply together to give me 27? 3 and 9. And then 9 goes down to 3 and 3. You guys remember taking the groups of 3 out? So those are 2 answers. Okay? Now, when we have 2 answers, we need to check to make sure they both work. Okay? The easy thing to do to see if they both work is just to go back to Desmos, type in log base 9, type in your original equation, log base 9 of A plus log base 9 of 3A, and then I'm going to come down here and say A, I want that to be square root of 27. Did it give me 2 back? Make sense? Or, simplified version would have been the 3 radical 3. Still gives me 2 back, right? Okay? So positive radical 27 is fine, and it works. If I put negative in, does it give me 2 back? No. Okay? Now, it's not always the negative root or the negative x value that provides an issue. What happens is, because of the logarithm, because of its domain, if I were to look at, log base 9 of x, that is that purple graph right there, right? Is that thing, so negative 3 radical 3 is negative 5.2. Negative 5.2 is where my cursor is. Are there any y values on that purple curve at negative 5.2? No. Okay? So logarithms are, basically what I want to say here is you cannot take the logarithm of a negative number. It's like taking the square root. You can't take square roots of negative numbers, right? So we cannot take logarithms of negative numbers as well. Okay? Not because there's a relationship between square roots and logarithms. It's just a similar characteristic. Does that make sense? Okay. So when you get multiple solutions, you're going to want to check those solutions to make sure that you don't have any that are what we call extraneous. We'll do one more here. Let's go log base 2 of x plus 1 plus then log base 2 of x plus 2 equals 3. What's addition turn into with logarithms? Multiplication. So we're going to rewrite this. And I'm going to be explicit with this. You could do this all at once if you wanted to. What? Yeah. You're an enigma. Yes, exactly. So log base 2. Okay, I'm going to write, so x plus 1 times x plus 2 equals 3. Yes, yes. If they were on different sides, you'd have to move them over first, and then if you're left with addition, you can combine them like this through multiplication. If you're left with subtraction, you'd combine them through division. But I said I'm going to do this explicitly because I want these, jump to a completely different notebook, there we go. I want to show that I'm going to multiply those two things together, right? When I multiply a binomial times a binomial, what word do we use to describe that process? Not explicit. Okay, multiplication, but you're going to multiply, you're going to distribute that over there, and then you're going to distribute that over there. What process is that called? You're going to FOIL, right? So we're going to FOIL. So what's x times x? X squared. X times 2, 2x. X, or 1 times x, and then 1 times 2, right? Now you can combine the 2x and the 1x, and that's going to give you 3x. Okay. Say it again. So this structure here is what we're talking about, right? We like it to be that. They can be shuffled because the commutative property of addition, we can shuffle those around, but we like it to be this way because of the next step that we're going to do. So we like our powers to be in descending order. So biggest one first, then the next smallest, and the next smallest all the way down to 0. Okay, I see what you're saying, yes. So now with the logarithm, we're going to take 2, raise it to the third, and that should come back and give us this thing here in the middle, right? Should give us x squared plus 3x plus 2. What's 2 to the third? 8. Okay, so at that juncture right there, at that step, we have an x squared and an x to the first. So now you cannot use square roots. Okay? If you have x squared and x to the first in the same equation, you cannot use square roots, and you have to use some type of factoring technique. And if you were going to use a factoring technique, you need everything equal to 0. So you're going to subtract the 8 from both sides. And we're going to get 0 is equal to x squared plus 3x minus 6. Okay? Yes. Say again? What I do with that 3? So you would take that base, So this is a logarithm, so I got to turn it into an exponent. So I take that 2 becomes that 2 right there. And the 3 that is here is that 3. So it becomes 2 to the third, comes back and gives me this argument. That's the definition of a logarithm. Now, at this stage, are there two numbers that multiply together to give you -6 and add to give you 3? Two numbers that multiply together to give you -6 and add to give you 3. What are your factors of 6? 1, 6, and 2 and 3, right? If I do that, if I make those both negative, do either of these rows add up to 3? Nope. If I make this one, negative, and that one negative, do either of these add up to 3? No. So what that basically tells us is that there are not integers that are going to be solutions for this. So you guys remember yesterday we built this thing here. We said x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. And the x actually needs to be out here. All right, you remember setting that thing up yesterday, right? Control C. Now I'm going to make this a negative. Okay. And now I'm going to define what A, B, and C are. So I'm going to say A equals, B equals, C equals. What is A in this problem? Okay, so it comes from that term, but A is the what part of it? A is the coefficient for it. A is just going to be 1. The coefficient out here is the 1. So when I say B, B is the coefficient for that term. So what's the coefficient of that term? 3. So coefficient's just the number. And then C is the -6 in this case. And if I look at those are my two potential answers. Is that okay with everybody? Now, there might be extraneous solutions. So what I'm going to do is take our original equation. I'm going to say log of base 2 of A plus 1 plus then log base 2 of A plus 2. Okay. And I'm going to see if I can make A this number here or that number there. Does that make sense? Okay. So what I'm going to do, I'm just going to make this really easy on us. What we can end up doing is just say, let's put A, let's rename that as A. Does that make sense? So I'm going to rename that as A. I come down here and hit enter on that. Okay, make sure I did this. Oh, I can't do it that way because this uses A. So this is what we got to do. We can do. I used A down here. You see how I used A, B, and C because this is programmed. So everywhere I see A, it's going to use that number. So let's down here. Let's use like I've used B. I've used C. Let's just use T. K is a good one. K. A lot of people like to use K. So now I come up here and say T is that value. Come down here. Does it give me 3? Does it evaluate to be 3? Does that make sense to everybody? Okay. Now I'm going to come back up here. I'm going to delete that one, and we'll let this one be T. Does it give me a problem? Okay. So this answer does not work. This T of -4.3 does not work. But this T of 1.37 did work. Okay. And the reason for that, think about this. This is negative 4.3. If I plug negative 4.3 in right there, what's negative 4.3 plus 1? It's negative 4.3 plus 1. Negative 3.3. Should we be taking the logarithm of negative 3.3? Can't take the log of a negative number. And that's why that solution doesn't work. Okay? That's another way. If you don't want to check using your calculator, you can plug your numbers back in and say, okay, does the answer I got plugged back in here, does it give me a negative where I've highlighted? Okay? And then you have to check there as well. And if you find one place that it gives you a negative logarithm, then it's an answer that does not work. Questions? There, I gave you, I have an assignment here. It's got 7 questions on it. And all right, so you should be able to see 7.6 day 2. We'll go a little bit further with this stuff tomorrow and then move on to something completely different later in the week.